grab a deck of cards. Any deck. Go on, I'll wait. Now give it a real shuffle. The order you are holding right now has almost certainly never existed before. Not in your lifetime. Not in all of human history. Not once in the entire 14 billion year history of the universe.
I know exactly how that sounds. Completely insane.
But stay with me, because by the end of this video, you will know it is true, and you will never look at a pack of cards the same way again. 52 cards. That's it. A children's toy that's been sitting in a drawer in your house for years. And yet hidden inside this ordinary little deck is a number so enormous that your brain genuinely cannot picture it. So here is the one question we are going to chase today. How many different ways can you arrange 52 cards? Let's start small, because the whole trick is to feel how fast this grows. Forget 52 for a second. Imagine you have just 3 cards. How many ways can you line them up? Go ahead, picture it. There are 6. Easy enough to check on the table in front of you. Here's why it's 6. For the first card, you have 3 choices. Once it's down, only 2 cards are left for the second slot. And the last card just falls into place. 3 times 2 times 1. 6. Simple. Now watch what happens when we add just one more card. With 4 cards, it's 4 choices, then 3, then 2, then 1. That's 24. Add a 5th card, and you jump to 120. Add a 6th, and it's 720. Notice something scary? Every single card you add doesn't just add to the total. It multiplies it. This number isn't growing. It's exploding. Mathematicians have a name for this runaway multiplication. They call it a factorial, and they write it with an exclamation mark, which is honestly the most fitting punctuation in all of mathematics. Because every time you add a card, you don't take a step, you take a leap. And remember, we still have 47 more cards to add. So, let's actually do it. 52 times 51 times 50, all the way down to 1. Multiply every one of those numbers together. As you climb from 10 cards to 20 to 52, the answer doesn't just get bigger, it leaves the world of things we can imagine entirely. And here is what you get. Roughly 8, followed by 67 more digits. 68 digits in total. Let me just show you the whole thing written out, because seeing it is the only way to start to believe it. There it is. That is how many different ways this little deck can be arranged. And if that just looks like a random smear of digits to you, good. That is exactly the problem. A number this size means absolutely nothing to a human being. So let's fix that. Let's make it real. Here's the usual move when a number gets big. Compare it to the stars. The observable universe holds something like 1 billion trillion stars. Written out, that's a number with about 24 digits. Sounds astronomical, right? Our card number has 68 digits. The stars don't even come close. Not even in the same universe. Okay, stars are too small. Let's try every grain of sand on planet Earth. Every beach, every desert, the bottom of every ocean. Scientists estimate that's about 7.5 quintillion grains, a number with 19 digits. We blew past that a long time ago. Sand isn't even worth mentioning.
Fine.
Let's go nuclear. How about every atom in the entire planet Earth? The whole thing, the oceans, the molten core, every mountain, all of it. That is roughly a number with 50 digits. 50. And our deck has 68. So the number of ways to shuffle these 52 cards is bigger than the number of atoms making up the world you're standing on, by a factor of 1,000,000 trillion. Just sit with that for a second. More ways to arrange one deck of cards than there are atoms in the whole Earth. I had to read that 3 times before I believed it. Let me put all of these side by side, not by their size, because you literally cannot draw that, but by how many digits each one has. Seconds since the Big Bang. 18 digits. Grains of sand on Earth. 19. Stars in the whole universe. 24. Atoms in the entire planet. 50. And our humble little deck of cards? 68. It towers over every single one of them. And remember, these aren't small things we're comparing it against. These are the biggest quantities in all of science. The deck beats every one of them. So how on earth do you wrap your head around a number like that? Well, there is one demonstration that does it better than anything I have ever seen. It goes like this. We are going to count to 52 factorial, 1 card arrangement per second, and I'm going to show you exactly how long that takes. Get comfortable. This is the part you'll remember forever. Stand still on the equator. Your job is simple. Wait 1 billion years, then take a single step forward. Not 1 step a second. 1 step every billion years. Then wait another billion years, take another step, and slowly, impossibly, begin to walk all the way around the entire planet. When you've finally walked the whole way around the Earth, which, at 1 step every billion years, takes longer than you can possibly imagine, you have earned the right to do exactly one thing. Remove a single drop of water from the Pacific Ocean. Just 1 drop. Then you set off walking around the world all over again. Step by step, billion years by billion years, lap around the planet after lap around the planet. Each full lap, you remove 1 more drop. And you keep going until the entire Pacific Ocean is empty, bone dry, every last drop gone. And when you finally drain the whole Pacific, you get to lay 1 sheet of paper flat on the ground. 1 sheet. Then you refill the entire ocean and start the whole thing over, walking the Earth, draining the Pacific drop by drop just to earn 1 more sheet of paper on the stack. You build that stack of paper higher and higher, 1 excruciating sheet at a time, until the pile finally reaches all the way up to the sun. 150 million kilometers of paper. And at that point, surely you have counted to 52 factorial, right? Not even close. When that stack of paper finally reaches the sun, you're not even 1% of the way to 52 factorial. In fact, you would have to repeat that entire process. Empty the Pacific drop by drop, build a tower of paper to the sun, more than 1,000 times over before your count is done. Let's try it the other way. Imagine you had started counting card arrangements, 1 every single second, at the exact instant of the Big Bang. 1 shuffle every second, for the entire age of the universe. 14 billion years, ticking away 1 second at a time. The number of seconds that have passed since the Big Bang is about 430 quintillion. That's an 18-digit number. But to finish counting our deck, you need a 68-digit number of seconds. So you would have to replay the entire history of the universe from the Big Bang until right now, again and again and again, billions upon billions of times over, and you still would not be finished. Which finally brings us all the way back to the deck in your hands. Humans have been playing cards for around 700 years. Now think of every single shuffle ever performed, every casino in Vegas, every poker night, every magician's trick, every bored kid on a rainy afternoon, for 7 entire centuries. Add them all up. Even with the most generous estimate imaginable, the total number of shuffles in all of human history is laughably, hilariously tiny next to 52 factorial. So tiny that the chance any 2 of them ever produce the exact same order of cards is, for all practical purposes, 0. So when you pick up a deck and give it a proper shuffle, you're almost certainly creating an arrangement of 52 cards that has never existed before in the history of the world. You are holding something genuinely, mathematically unique, a configuration the universe has never seen, and, in all likelihood, never will again. But hang on, why are there 52 cards in the first place? Why not 50 or 100? The answer is a little bit of history and a little bit of accident. Playing cards arrived in Europe in the 1300s, coming through the Islamic world from a deck used by the Mamluks of Egypt, and that deck already had 52 cards in 4 suits. Europeans kept that structure, swapped the symbols for the hearts, diamonds, clubs, and spades we know today, and because the French version was so cheap to mass produce, it quietly became the standard across the entire planet. Nobody ever sat down and chose 52 as the perfect number. It is an accident of history that simply stuck. Though there is one beautiful coincidence people love to point out. For suits like the 4 seasons, 13 cards in each suit, like the 13 weeks in each season. 52 cards, like the 52 weeks in a year. And if you add up the value of every card, you get 364. Add a single joker, and you land on 365, the number of days in a year. Now, is that the real reason there are 52 cards? Almost certainly not. It is a lovely coincidence, noticed long after the fact, not the cause. So here is what I want you to do. Go find a deck, shuffle it, and really look at it, knowing that the pattern in your hands has, in all probability, never appeared anywhere at any time since the beginning of everything. You are holding a tiny, unrepeatable moment in the universe. If that just rewired your brain a little, subscribe, because we find this kind of hidden wonder in the most ordinary things. I'll see you in the next one.